Hello class, in this tutorial I'm going to show you what we need to do for problem 13.38. Again, this can be done using the data analysis tool pack, all of it except for the Durbin-Watson, or it can all be done through one menu with PHStat2, so that's what I'm going to show you. Now if you recall, two important things you need to do and recognize when running a linear regression is identifying what your independent and dependent variables are. Remember, your independent variables should be denoted by X and your dependent variables denoted by Y, and it's helpful to arrange the data file such that your X's or independent variables are on the left and your dependent variables or Y variables are towards the right. We have this ice cream data file here. And basically we want to be able to run our regression, but also calculate our Durbin-Watson to see if there's any evidence of a positive autocorrelation. So, very easy to do. We just go to add-ins, PHStat, regression, simple linear regression. Our Y, we know that it's our sales column, and I've labeled it so it's easy to see. Our X variable is temperature. We just select that. And it's easiest, and I just found everything just runs nicely. If you just check the box for everything, scatter plot, Durbin-Watson, you don't need the confidence interval. So the title will just be the name of the problem. And we're ready to run our regression. Very easy to do. Just click OK. Now, should be similar output to what you're seeing. You need to pay attention to your multiple R, that's your correlation, your R squared, which is your coefficient of determination, your significance, which basically tells us that the relationship that we have here is significant, and that's helpful for problem 13.52 to know why you need to run the regression. And then our particular 2 points of interest here are intercept and slope. Again, using the formula y equals b plus mx, you can predict any particular x value using that formula based on this slope. Now, the last part of the problem was asking about the Durbin-Watson. And what's nice about it, PHStat2, it gives you this number, it calculated it for you. However, you're not done. You have to compare that number, that calculated number, to a table value. And unfortunately, there's no syntax or anything online. You got to do this manually. And what I have here is let me find it. Our table. I took it from the book. And basically, there's a few things you need to look at with the Durbin-Watson table. You need to know your alpha level, which is 0.05. You need to know how many independent variables we have. That's the K. We know we only have one. And the next thing you need to do is go down the list here for your sample size. We know that we have 21 records, so we just need to go down to number 21. But then for each K value, there's a D lower value and a D upper value. You want to focus in on the DL value. So you just do a crosswalk of the sample size and just go down to that sample size in the DL column until you find this particular value of 1.22. You need to compare that 1.22 to our calculated Durbin-Watson value, which was 1.639. Now what you just need to know is if your calculated value is below, so if 1.63 was below 1.22, you can conclude there's evidence of autocorrelation among the residuals. However, it's not. 1.639 is obviously greater than 1.22, so in fact it's even greater than the upper value of 1.42. So there is no evidence here of autocorrelation. So the analysis is suitable for regression. That's it.